We're going to be looking at graphing absolute value equations and inequalities today. All right, so absolute value, we've looked at what it means. We're going to look at the shape of the graph now. When you graph an absolute value equation, you get a graph that looks similar to like this. It's always going to be V-shaped, with either the V going up like this, or you might also get a downward looking V, but it's always going to be V-shaped. When you want to find the vertex, vertex is the point where the V comes to a point, the vertex point. It's always going to come from this general equation of a absolute value function. The x value of where that vertex is always is going to be h. So the h, to get that, it's always whatever makes it equal 0. So when you have this x minus whatever in there, if you set it equal to 0 and solve it, that's going to be what your h is. So h is going to be the x value of that point. The y value of that point is going to be whatever k is. So hk is your vertex. If the absolute value function is greater than 0, where a is greater than 0, then it's going to open up. If the absolute value function, if you have a less than 0, then it's going to open down. Okay, and by what we mean by that is it's going to look like this, whereas this one's going to open up like this. Okay, so let's look at some of these here. For each one, we're going to try to determine if this opens up or opens down, and also where the vertex is. Okay, so when you want to figure out if it opens up or opens down, look in front. Is it positive or negative? This one is positive, so this one's going to open up. It's going to look like this. Okay, now let's figure out where the vertex is going to be. So the vertex comes from here. Set this equal to 0 and see what you get for x. So if you go x minus 2 equals 0, the x coordinate is going to be 2. So the vertex on this one is going to be 2, and then whatever this number is your y. 2, 3 is the vertex. Okay. B. Okay, let's see if it opens up or opens down. Negative, so this one's going to open down. And again, what we mean by that is you're going to get it shaped like this. On this one, for the vertex, take what's in the absolute value, put it equal to 0, and see what you get. This one is going to get -5. So the vertex here is at -5. Now it's kind of tricky on this one because we don't see any numbers over here like we did on the last one. If you see nothing, that means it's like +0. And so the vertex on this one's at the point -5, 0. Okay, number 9. Or I'm sorry, letter C. On this one, look in front again. It's positive, so this one's opening up. It's going to look like that. What's the vertex? Okay, if we put what's in the absolute value equal to 0 on this one, it is 0. And so the vertex is going to be 0, comma, our y point comes from there, so 0, 7. So that would be the vertex on this one. Okay, why don't you pause the video and try D and see what you get. All right, let's check it out. This one you should have had opening down because there's a negative in front. And then the vertex on this one, you should have had it as 3, -5. Okay, -5 because it's -5 here. And 3 because 3 is the number that makes that equal 0. Okay, so next example, now we're looking at how to graph these out here. So to graph this one, first we're going to do the same thing, determine the vertex point on this one. Vertex is going to be -1, -2. Again, -2 is that point right there, and the -1 is because -1 plus 1 makes that equal 0. Okay, so now we know that point on the graph. Okay, we know we're going to have a point -1, -2 right here where that's going to come to a V. Some other stuff we know. from before it's positive in front, this one's going to open up. So we should see when we're done a V shape like this. Okay, now we'll give you some ways you can get the rest of the graph. One is now to graph and get some other points. So if we know the vertex is -1, -2, this graph is symmetrical on each side. So we can put some points bigger than -1 and some points smaller than -1 and figure out what those are going to be. For example, if we put 0 in here, okay, if we put 0 in place of x, what is this going to equal? So here's our function. If we replace x with 0, what's this going to come out to be? Well, 0 plus 1 is 1. Absolute value of 1, still 1. 1 minus 2 is going to be -1. And so now we know this is going to be -1. Similar, if we put in -2, it should also give us -1. Just to show you that, we'll solve it out and see what you get. If you put -2 in here for x, -2 plus 1 is -1. Remember though, what does absolute value do? Makes it positive. It's the distance from 0, so that's +1 minus 2. You should get the same thing, which we did. Okay. And we could keep plugging numbers in here and get it that way. Another way you can get a table of values is with the calculator. To do this on the calculator, what you're going to do is hit the y equals button, which is in the upper left-hand corner there. That's highlighted in red. Type in this function. To type in this function, if you go to math, okay, then scroll over to the second category, that says number. This number 1 option, ABS, stands for absolute value. If you hit it, an absolute value sign pops up on your graph. So now type in the function x, which is this red highlighted one here, plus 1. Okay, now you got to hit the over button to get outside the absolute value and hit -2. And then if you hit the second button and where it says graph, right above graph, it says table over here. Okay, so the button in the upper right-hand corner, out pops the table. So now if you want to find any of these values, you can by scrolling up or down. Here's 1. When x is 1, it shows you that y is 0. So that one's going to come out to be 0. If it's symmetrical, then this one should also come out to be 0. And just to show you, if we scroll up to where the negative value is here, we should get -30. There you go. So it is the same thing. Okay, so if you want to graph it that way by points, now you just plot all those points on the table, and we should get this V shape we're looking for. -30 is that point. -2, 1 is that point. -1, 2 is already on there. That was our vertex. 0, -1's there. 1, 0's here. It should continue in the same fashion here, this way and this way, and it's opening up like we said it should because there was a positive value. Now, that's one way to graph it. If you have this function in your calculator, if you actually hit graph, you can get a graph of this one. You might need to hit the zoom button and then pick number 6 here, the standard graph. That's like a 10 by 10 graph to see it a little better. Same graph that we see that we just graphed there. Another way you could get this, if you know it's going up, whatever number's in front of x here, it kind of ends up being your slope. So like when we think slope intercept, there's a 1 there. So on the right side of this, once we start our vertex, we're going up 1 over 1, up 1 over 1, up 1 over 1. You got to remember on the other side though, it's going to be the reverse. So up 1, left 1, up 1, left 1. And you can get it that way too. All right, last thing with this, what's the domain and range? Okay, domain again is our x's. Okay, what x points do we see here? Well, if you follow these points up to the x-axis, it looks like it's going to be all the points because this is going to continue going here. So we're going to have all the positive values of x. If we continue down here, we're going to have all the negative values of x. We're going to have all real numbers here for this, all real numbers. Okay, so that's your domain. For your range, that's your y values. It's going to continue up forever, so we're going to hit all those positive values. We do have a minimum value down here, though, at our where our V point is. The lowest this gets is -2. You can see all these values and all these values are bigger than -2, but -2 is the smallest one. And so for our range, it's y has to be bigger than or equal to -2. All right, flip it over to the back. Let's try graphing some more of these. So for example 3, they want us to graph this one out. Vertex again, we're going to looking at what makes that 0. 4. 4 minus 4 is 0. So we're going to have 4 comma, and then whatever this number is, that's your y part of the vertex, so 1. So 4, 1, right there. Okay, now to get the rest of the graph, we're looking, is it opening up or down? This one's positive, so it's opening up. And then we can look at what the slope is to get some of the other points. On this one, since there's nothing in front of the x, slope is going to be 1. And so on the right side, we should be going up 1, right 1. On the other side, we should be going up 1, left 1. So this graph is going to look like that. If you're unsure, you can always go back and do a quick table. Okay, again, put the vertex in the middle. Just to show you this works, let's test 5. So if you were to put 5 in here, you got 5 minus 4 plus 1. 5 minus 4 is 1. Absolute value 1 is 1. 1 plus 1 is 2. 5, 2 should be a point here. If you look at the point 5, 2, that's right there. Definitely that's part of our graph. So it looks like we got it. And if you test some of the other points, we know 3 should be symmetrical. It's 3, 2 on our graph. Yep, 3, 2 is the point right there. You can see that's also on there, so we got the right graph. All right, last part, domain and range. Again, you can put any number you want in for x here, and we can figure it out. So this is, again, all real numbers. Our range, it looks like for our y's, the lowest this gets is 1. And so our range is going to be y bigger than or equal to 1. Okay, number 4, graphing this one out. Why don't you pause the video and try this one on your own and see what you get. All right, let's see. Vertex you should have had as 2, -4, because -4 there, and 2 minus 2 makes that 0, so 2, -4. That point is right there. Okay, graphing this one now. If you look at the slope again, it's 1, and we got a 1 opening up because it's positive. So if we go up 1, right 1 on this side, up 1, left 1 on the other side, that's the graph on this one. Okay, domain again, all reals, and this one, our y should be greater than or equal to -4. That's the lowest y value we see. All right, number 5. Okay, vertex. What makes the absolute value part 0? Well, here, if we put it equal to 0, it is 0. So our vertex is going to be 0 on this one. Our y value for the vertex is going to be -3 because we do get that -3 off the back. Okay, if we look out front, this one's positive again, this one's opening up. But here now we got a 2. That tells us the slope is going to be up 2 over 1 from that point. So if we find our point 0, -3, that's there. Okay, now our slope is up 2 over 1, up 2 over 1, up 2 over 1 on this side. On the other side then, we know it's got to make a V shape, so up 2 left 1 on the other side, so that it's symmetrical. Now connect these, and that's the shape of the graph. Okay, again, you can try if you want to test it just to make sure, you can do a table. You're going to get the exact same points. If you plug in 0 on this one, just to show you, absolute value of 0 is 0. 2 times 0 is going to be 0. 0 minus 3 is -3. So that's our vertex point. If you plugged in, say, a point 1 less than that, like -1, absolute value of -1 is +1. +1. 2 times 1 is 2, minus 3 is -1. So -1 should be a point, and just looking at that, yes, that point goes through our graph. you know there should be a symmetrical point then at this point, and you can see right there. So you get the same points if you make the table. Domain on this, all reals, because you can put any number still in for x there. Our range, the lowest we see is right at -3 there. So y's got to be bigger than or equal to -3. Okay, next one. We want to graph this one out. Okay, what's the vertex? What makes this 0? Again, if you can't see it, just put equal to 0 and you can find it out. It's 2. So we got 2 comma, our y value is going to be 5. So on the graph, let's go find that point. 2, 5 is right there. Okay, next, look, which way is it open? This one is opening down. It's negative. So we should be getting a shape like this one here. Okay, so we know you got to go down. All right, what's the slope then? Well, being that it's negative and there's no number there, the slope's -1. So if we start at this point, we need to be going down 1, right 1 from there. Got a slope of -1 on the right side. We got to be symmetrical, so on the other side, should be going the other way here. Okay, so we got points there, there, there. Now, one other difference on this one, we don't have an equal sign. We have a greater than or sorry, less than or equal to sign. So that tells us we got to decide, should we use a solid or dash or dotted line? Anytime you got equals to, we want to use solid line. So we're going to connect these with a solid line. Now we also got to decide, should we shade up or shade down? If it's less than, if we want all the points less than this, we definitely want to shade down. So on this one, all the points that are solutions are all going to be underneath this absolute value graph. So we shade everything there. They don't ask it, but if we were to find the domain and range on this one, again, domain would be all real numbers. You can put any number in there for x. The range on this one, you got to be careful now. Okay, it's y again, but if you look, since it's opening down, the highest this one gets is 5. It never goes above 5. So if we were writing the range on this one, we would say that all the y points are going to be less than or equal to 5, not greater than, because all the solutions are below that. Number 7, graph the absolute value inequality. So again, we got an inequality one here. We're going to have to do some shading. Let's find our vertex first. It's going to be 0, since we don't have any other numbers in there. 2, which is right here. Our slope on this one, we can see is -3 or -3/1. Okay, and since it is negative, it's going to be opening down. So we want to start at our point and go down 3, right 1, down 3, right 1, down 3, right 1. Other side's got to be symmetrical. So go down 3, left 1. Okay, now we got to check what kind of line should we be using. This one should be a dashed or dotted line because it doesn't have the equals to. So when we're connecting these, don't use a solid one. So it looks like that. Okay, now we got to figure out what kind of shading should we do. If it is on this one greater than, then we want to make sure that we're shading up above that. So everything above should be shaded on this one. So here we're shading everything above the absolute value graph, and all of those would be their solutions. Okay, try some now out on your own.